Finding solutions to systems of linear equations. First of all, what is a solution? Well, a solution to a set of linear equations, you'll notice I have a picture of a graph here. Our first equation has a positive slope. Our second equation has a negative slope. And they are intersecting right here at a point. And so this point right here would be the solution to the systems of equations. 3, -2. How do we find solutions? We have 3 methods that we can use. We've talked about 2 of these solutions before, and we'll be learning the third one. The first way is graphing. The second way, substitution. And the third way is one, again, that we haven't learned yet. It is called elimination. This is our goal this week, to master elimination when finding solutions to a system of linear equations. Before we move on, let's talk about the 2 types of linear equations we are used to seeing. The very first one that most everybody is used to is y equals mx plus b. What form is this in? Slope-intercept form. We know that it's slope-intercept form because m represents the slope and b represents the y-intercept, where the linear equation crosses the y-axis. Our other form is which form is this? Standard form. Standard form is when the ax and the by, meaning the x part and the y part, are on the same side of the equals sign. So here is our equals sign, and you'll notice that the x part and the y part are on the same side. That's what defines standard form. Okay, so a quick review on graphing. Let's look at our very first equation here. We have y equals 4x plus 3. If I was to graph y equals 4x plus 3, my first point would go at 3 on the y-axis. And from there, I am supposed to have a slope of 4, which remember means 4 over 1. So up 4 over 1, up 1, 2, 3, 4, right 1. So that went way off my graph. We also can do the reverse of up 1, right 4. I said that totally backwards. We also can do the reverse of up 4, right 1, which would be down 4, 1, 2, 3, 4, left 1. Again, down 1, 2, 3, 4, left 1. And so this linear equation would look like this. And my second linear equation starts at -2 on the y-axis. Now its slope doesn't have a number written in front of x, but we know that means 1 over 1. And it's negative, so we should go downhill. Down 1, right 1. Down 1, right 1. Down 1, right 1. The reverse would be up 1, left 1. Up 1, left 1. Up 1, left 1. And we can see that our 2 linear equations intersect. And so our solution would be right here. The solution would be at -1, -1. This is probably the easiest way that we know of finding solutions at this point, but it's not always the easiest version to use. So over here we have a question. It says, when do we use this method? We use this method when both equations are in slope-intercept form. So looking at our 2 equations over here, they are both in y equals mx plus b, which is slope-intercept form. If they're in that form, it's super easy just to graph them and see where they intersect. Our second type of method is substitution. If you notice your two equations that you're given, the first one is in what form? The second one is in what form? And so we have slope-intercept, and we have standard. This would be the case when you would want to use substitution, when one of your equations is in slope-intercept form and the other one is not. Here's how substitution works if you forgot. We know that y equals 6x minus 11. So we can substitute 6x minus 11 into the standard form equation where y is. So it would look something like this. We have our second equation, negative 2x subtract 3, but instead of writing y, we use parentheses and we plug in 6x minus 11 and then equals negative 7. So all that we've done is we've substituted 6x minus 11 in for y into the other equation. This is nice because our new red equation has all x's. We don't have multiple variables. So solving away, this negative 3 needs to distribute to the 6x and the negative 11, which would give us negative 2x subtract 18x. Negative times a negative is a positive 33 equals negative 7. Now on the left side, we notice that we have some like terms. Combining negative 2x and negative 18x gives us negative 20x. Plus 33 equals negative 7. Now creating a zero pair by subtracting 33 on both sides, we are left with negative 20x equals negative 40. Divide our negative 20 on both sides, and x equals 2. So we're technically halfway done. We need an ordered pair x comma y. So what we do is we plug x equal 2 into either of these equations that we started out with. The easiest one to use is the slope-intercept form. It's less work, so I'm going to plug x equals 2 into x right here. You can use the standard form equation, it just takes more work. So y equals 6x minus 11. We are going to plug in 2 for x. So y equals 6, parentheses, plug in 2 minus 11, which gives us y equals 6 times 2 is 12 minus 11, and so y equals 1. So our solution to this system of equations is 2, 1. That means if we were to graph both of these, which that wouldn't be the best way to do that because one of them is not in slope-intercept form, but if we did graph these, they would intersect at 2, 1. So off to the right it says, when do we use this method? We use this method when one equation is in slope-intercept form. And I'm going to add to this, not when one equation, but at least one equation is in slope-intercept form. What about this situation? Our top equation is in what form? Our bottom equation is in what form? So the top equation is in standard, and that's because the x and the y are on the same side of equals. The second equation, we don't know. It's not in y equals mx plus b, it's in x equals. We don't have a name for this form, but substitution is still the best method. This is still a linear equation. And what's being said here, we know that x equals 2y plus 11. And so because x equals that, wherever we find x in the other equation, we can substitute in. So we're going to substitute 2y plus 11 into x in the upper equation. So we have negative 7x, but instead of x, we're putting in 2y plus 11. And then subtract 2y, and then equals negative 13. Distribute negative 14y, negative 77, minus 2y equals negative 13. Combine like terms. Negative 16y minus 77 equals negative 13. Create a zero pair by adding 77 on each side. Negative 16y equals negative 13 plus 77 is 64. And then divide negative 16 on both sides. And we get y equals negative 4. Now we're halfway done. We have the y value, but we still need the x. Same goes on the last question. The standard form equation you can plug into, but the one that's in this form is going to be easier because x is already alone. This is like the opposite of slope-intercept form. It's just the x and the y are flipped. So if I plug in, it's going to say x equals 2y plus 11, but we're going to plug in negative 4 for y. So now we have x equals negative 8 plus 11. And so x is going to equal 3. So the solution, x comma y, is 3 comma negative 4. That means that if we were to graph these two linears, they would cross at 3 comma negative 4. Okay, when do we use this method? On the last slide, we said to use substitution when one of the equations was in slope-intercept form. Let's say when one of the equations has an isolated variable. So what that means is you have y equals, you have x equals, you have whatever variable equals, and then all of your stuff. So in this case we did. We had x equals 2y plus 11. The x is what's isolated. It's on one side all by itself. The third method is called elimination. We have not yet learned this one. That is our goal this week, to learn elimination. But when do we use this method? We use this method when both equations are in blank form. And if you look at both of our equations, what form are they both in? Standard. So you use elimination when both forms are in standard. And standard form is when x and y are on the same side as the equals. X and y are on the same side of equals. So let's go through a couple practice questions. Which method to find the solutions? Graphing, substitution, or elimination? Graphing. We would use graphing because both are in y equals, which is slope-intercept form. Which method to find solutions? Graphing, elimination, or substitution? Elimination. We would use elimination because they are both in standard form. They both have x and y on the same side of the equals. Which method to find solutions? Graphing, substitution, elimination? Substitution. If you look at the first equation, this is supposed to be a y. Oopsies. X is isolated. We know that x is by itself and it equals 7y plus 1. So we would take 7y plus 1 minus 1 and we would plug it in for x. Substitution. Which method? Elimination. Both equations are in standard form. Which method? Graphing. Both equations are in y equals mx plus b, or slope-intercept form. Which method? Substitution. The bottom equation's in slope-intercept form, y equals 2x minus 1. So we could plug in 2x minus 1 for y into the upper equation. So what is our goal this week? We need to be able to solve for solutions to systems of linear equations in 3 ways. We need to be able to use the graphing method. We need to be able to use a substitution method and the elimination method. This is what we are going to be studying this week. Oh, I spelled it wrong. Elimination. The plan is that you are going to have a test on this material at the end of this week. So please make sure that you're staying on task and staying up to par on every daily plan.